Hi everyone, happy Friday. So this video is going to be just a very quick recap of what we've learned because we're well into the end of week 4. We've got week 5 coming up, and there's actually been a ton of information. I hope that you're finding this class engaging. I hope you're learning something new. If you've had science before, I hope you're able to go a little bit deeper into it. So the first thing that we learned in week 1, we focused on what are the natural sciences. What is science? What is the aim of science? So everything from curiosity, aiming to answer questions about the natural world around us. And we learned what some of those topics were. So we talked a little bit about biology, earth science and geology, astronomy, physics, some of the things that fall into the realm of the natural sciences. And then what we had you guys do was pick an article, something of interest to you. And then we started to focus in on, well, okay, how do we know what's real and what's not real in science? And what's the process through which our article and other things that we've read made themselves valid? Did they use the scientific method? Did they go through the process of asking a question, forming a hypothesis, performing the research, and were you able to see that evidence in your actual article? And then we moved on to, and this is my favorite, one of my favorite parts, how do we know what to believe anymore? And this kind of relates back to the other video that I had for you this week. And part of how we showed you to do that was an evaluation rubric. Is it credible? Is it relevant? Is it current? Can you find out who wrote it? Can you find out more information about the scientist? Was it peer reviewed? Did it come from a website that had lots of commercials or advertisements? Was that website a nonprofit? Was it a government agency? Or was it a for-profit agency that actually took donations? Was it represented by a special interest group rather than a group of scientists? So we gave you some of those tools, hopefully, which all of you did a very nice job on using to actually evaluate and find out whether or not your source was credible. We also learned what science was not. We talked a little bit about, in some of the articles you read, about ghosts or the supernatural or astrology. And not that you can't have opinions or believe in those things, but really what science is about is taking a look at the natural world around us. Not that those things wouldn't fall into that category, but then collecting evidence to support our observations. So when we talk about proving things in science, we're really talking about, is there a wide enough body of accepted evidence? Has the experiment been repeated over and over and over again by scientists and groups and peer reviewed all over the world to make it something that we can believe to be true or hold to be true? And then we got into how science and how scientists over time, and this was our week 4 work, have been controversial. And really, new ideas and new evidence doesn't always come so easily, or accepting that new evidence doesn't always come so easily. And we saw that in a number of the scientists that you chose, everybody from Copernicus to Einstein. So you guys chose some great scientists to sort of show how science can be difficult and unaccepted, and some of these people were considered to be heretics in their time. And what that process can look like for science. Science isn't always easy, and accepting those new beliefs isn't always easy. We even saw some of that evidence during our week 1 conversation when we took a look at continental drift and Alfred Wegener. You know, nobody believed him in his time. They thought he was crazy. First of all, he wasn't a geologist. He was a meteorologist. And even though he had overwhelming evidence that really looked like it supported the plates moved and were once joined in a supercontinent called Pangaea, which it turns out they were, but nobody believed them. They sort of laughed him out of geology conferences. And it wasn't until they found out how, or the mechanism that plates moved, and that was people like Harry Hess and Marie Tharp, and they understood seafloor spreading, that finally gave weight to Wegener's argument. So I hope you enjoyed this week of just seeing how difficult it can be for change in science. And then finally, this idea of how and who and what can we believe? And I hope that that will be a recurring theme going forward, especially in light of me being a recipient as a science teacher of very solid, important looking information that said that humans do not impact climate change. And that's pretty scary to me. So I'm really glad that you all are taking this course. You know, if you get only a handful of things from this, I hope one of those things is how to approach any information in your life with a critical eye, and how to go those extra few steps deeper into seeing whether or not the information that you're taking in is credible and whether or not it can be believed. So that's a quick recap. I'm looking forward to seeing your next projects. Grading is almost up to date. I'll definitely be finished with week 3 within the next day or so. And I look forward to week 5. On Monday, I'll definitely have a post introducing week 5 for you guys, and we'll move on from there. Thanks and have a great weekend.